Hello everyone, welcome to the paper discussion of your LTC MPL chemistry for unit test number 5. So guys, let's get started. The first question that came in your examination is, in the hydrogen atom, the radial distance is maximum between. So first of all, radial distance for any orbital is equal to Rn, that is equal to R0 into n square by z. Since they are talking about hydrogen atoms, z is equal to 1. So that will be equal to R0 into n square, where n is the number of orbit. So if you can see, the number of orbits are 1, 2, 3, 4 and 5. So for R1, it will be equal to R0. For R2, that is for the second orbit, the radius will be 4 times R0. Then for R3, it will be 9 times R0. Then for R4 it will be 16 times R0, and for R5 it will be 25 times R0. So the radial distance between, radial distance is maximum between. So if you see, the maximum difference is between 16 to 25, and hence the right answer will be option number 4. So question number 51, option number 4 is the right answer. 52, de Broglie wavelength of the particle this much. Linear momentum of the particle in this. So since it is gram per centimeter, can I convert this thing into centimeters? That is 6.625 into 10 raised to minus 7 centimeters. And we know that lambda, de Broglie wavelength, is equal to h upon p, that is Planck constant time momentum. So that will be 6.6. This is joule second, 10 raised to minus 34 joule second. So I can clearly consider this thing as 10 raised to minus 7 per second. Then momentum we need to calculate. Momentum we need to calculate. So that for momentum will be equal to 6.6 into 10 raised to minus 27 whole divided by wavelength is 6.6. I am just considering that much, into 10 raised to minus 7. So it goes up, this get cancelled. This 10 raised to minus 7 goes up, becomes 10 raised to minus 20. Hence the answer will be 10 raised to minus 20. This one. 53. The maximum number of electron possible with n plus l equal to 5. So n plus l is equal to 5. So that is 5 plus 0 is equal to 5. That means I am talking about 5s. Then 4 plus 1 is equal to 5. That means I am talking about 4p. Then 3 plus 2 is equal to 5. That means we are talking about 3d. Then 2 plus 3 is equal to 5. That means we are talking about 2f. Certainly this orbital is not possible. So these are the only possible combination. In s orbital, that is 2 electron, p has 6 and t has 10. So total is 18 electrons. Hence the right answer will be 18. 54. Assuming that the energy of multi-electron atoms depends only, this word is important, only on principal quantum number, that is n. So energy is directly proportional to n. Potassium belongs to dash block of periodic table. So potassium has atomic number as 19. That will be equal to 1s2, then 2s2, then 2p6, then 3s2, then 3p6. So that goes to 18, and then 3d1. So it belongs to d orbital. So answer has to be D. 54. Option number 3 is the right answer. 54. In a photoelectric effect experiment, a graph is plotted between kinetic energy of a photoelectrons, that is y-axis, versus frequency of incident radiation, that is on x-axis. The magnitude of the slope will be equal to. So we know that kinetic energy is equal to, in terms of frequency, h nu minus h nu naught. Kinetic energy is taken as y-axis, whereas frequency of incident radiation is taken as x-axis. So can I say it will be y is equal to, y is equal to mx minus c. That means it's a straight line. It's a what? This is minus c. Intercept is negative. That means straight line with a negative intercept, something like this. But its slope will be what? Its slope will be what? H, that is Planck's constant. So that magnitude of the slope is equal to Planck's constant, right? So question number 55, right answer is 51, first option. 55, first option. 56, both 3s, 4s orbital have same number of angular nodes? Answer is yes, same, because angular nodes in all the s orbital is equal to what? 0, because angular nodes is equal to L, and s is equal to, for L value, that is azimuthal quantum number for s orbital, is 0. Both 3s and 4s orbital have same number of radial nodes? No. 3s has 2 radial nodes, whereas 4s have 3 radial nodes. So statement, and if you want to calculate radial nodes, that will be equal to n minus L minus 1. So 3 minus 1 is 2, 4 minus 1 is 3. Okay, so statement 1 is correct, statement 2 is incorrect. So I'll go with 56. Option number 2 is the right answer. 57. Which of the following shows plus I effect? Negatively charged species shows plus I effect. So 55. Option number 3 is the right answer. Sorry, 57. Option number 3 is the right answer. 58. Greater stability of methyl carbanion over tertiary butyl carbanion can be explained by inductive effect only. Okay, so option A only. Okay, we have A only. Yes, we have A only. That is 58. Option number 1 will be the right answer. 59. The most reactive compound among the following SN1 reaction. Most reactive towards SN1, that means stable carbocation. More the stability of carbocation, more is the reactivity. So here it is in carbocation, this cannot form stable carbocation and carbocation. Out of all this thing, I can say this thing, it's in 3-degree carbocation, resostabilized. Best answer. So 59, option number 2 is the right answer. 60. Identify the incorrect statement. We have to identify incorrect statement from the following. Water can be used as solvent in SN1 reaction. Answer is true. So that means it's not the right option, because we need to calculate incorrect statement, but this is a correct statement. I minus is a better leaving group than F minus. True. This is also true, hence not the right answer. The product of SN2 reaction is always a racemic mixture. Wrong. And hence this is the right option. So question number 60 is the option number 3 is the right answer. Benzene derivative electron migration effect observed. So NO2 is minus I minus 1. So A is 3. A is 3. Exactly where is A is 3? So I'll go with 61. Option number 3 is the right answer. Okay, because in A, the only option that has 3 is A. Okay, that is option 3. 62. How many of the following species can act like nucleophiles? This is 5-bonded nucleophile. This has lone pair, and hence it acts as an neutral nucleophile. This is an ambident nucleophile. This does not act as a nucleophile because it does not have any lone pair, whereas water again has a lone pair. So out of all these things, how many? 1, 2, 3, 4. So option number 3 will be the right answer. Okay, next. Incorrect statement among the following. Ethyl alcohol and dimethyl ether are pair of functional isomer. True. N-propyl and isopropyl alcohol are pair of positional isomer. True. Ethyl methyl ketone and diethyl ketone are pair of homologue. True. Secondary butyl chloride and N-butyl chloride are pair of chain isomer. False. These are chain of position isomers, and hence option number 4 will be the right answer. Okay. Next. The absolute configuration of the molecule. So according to SIP rule, this is 1, this is 2, this is 3, this is 4. So if we'll say it rotates towards anti-clockwise, but since fourth priority is on vertical, we have to change the configuration. So it looked like S, but it is actually R because we have to invert it. Hence option number 3 will be the right answer. Okay. 60. The number of structural isomeric primary alcohol of the formula this. We need to consider primary alcohols with this given molecular formula. So if we'll calculate its degree of unsaturation, it will come out to be 0. With 5 carbon atom, the possible chain structures that you can draw is this: first, second, and third. These are the 3 possible structures that you can draw. Okay, so 1 degree I can count over here: 1, 2, 3, and 4. So the total primary alcohol that you can have in this molecular formula is only 4. So 65, 4. That is option number 2 is the right answer, because total 4 can be only drawn. 66. Ethyl bromide, aqueous, it is substitution. Ethyl bromide, alcoholic, it is elimination. So substitution, elimination. And then 66, option number 3 is the right answer. 67, an electron in the 6th orbit of hydrogen atom de-excites to ground state. That means first orbit. In all possible ways. Number of emissions of spectral length. Simple. It is n minus 1 by 2 emissions. So that is 6th into 6 minus 1 is 5 by 2. That is how much? 15. Right? So 15 is option number 2. So option number 2 is the right answer. Okay. 68. Electron gain enthalpy values for first 4 chalcogens. Okay, chalcogens, that means oxygen family, are randomly given as this. Electron gain enthalpy for sulfur. In chalcogen, sulfur has highest electron gain enthalpy and oxygen has lowest electron gain enthalpy. So out of this thing, the highest values 200, 141, 190. Okay, so 200 minus 200 will be the right answer. So option number 3, 68, option number 3 will be the right answer. 69. The electronic configuration of 4 elements is given below. One of these 4 elements, least electronegative elements according to Pauling scale. Okay, so least electronegative. I will easily cancel out 3 and 4. This will not have least because they belong to second orbit, and second orbit will experience more force of attraction and their electronegativity will be more. Talking about first and second, I can see 3p5, that means halogen, the electronegativity will be by default more than 3p4, which is a nitrogen family. Okay, sorry, not nitrogen family, which will be the carbon family. Okay, clear? Or oxygen family, not oxygen, sorry, it's basically oxygen family, extremely sorry. So this is halogens and this is oxygen family. And we know that halogens are more electronegative than oxygen family. So option number 2. So 69, option number 2 will be the right answer. 70. Identify the correct statement. Okay. Identify correct statement from the following. Nitrogen cannot show pentavalency. This is wrong. Sorry, this is right. Okay. This is right. Mostly, yeah. Nitrogen cannot show +5 oxidation state. Nitrogen cannot show +5 oxidation state. Okay, boron cannot show +3 oxidation state. Cool. Okay, and we need to identify boron cannot form trivalent ion. So this is also right. We need to identify correct statements. Okay, so these two are correct, whereas nitrogen cannot show, it can show +5 oxidation state. Okay, that is in N2O5 it can show. Okay, if we'll calculate oxidation state in N2O5, you'll see that boron cannot show +3. Yes, it can show +3 in BF3. So this is wrong statement, this is wrong statement. A and D is right, so option D will be the right answer. Okay. 71. Atomic radius of fluorine and neon are respectively. So we know that neon will be more than fluorine atomic radius in terms of atomic radius. Okay, so the only option that justifies is option number 3, where fluorine is less and neon is more. Rest it is equal not, it is equal not, and here shows fluorine is more than neon, so that's not the right answer. So option number 3 will be the right answer. 72. In general, all the following periodic properties across the period from left to right. Okay. In general, all the periodic properties increases across the period from left to right. From left to right, electron gain enthalpy increases, ionization enthalpy increases, atomic radius decreases, electronegativity increases, and hence option number 3 is the right answer. Okay. 73. Beryllium and aluminium show similar chemical properties. True. Okay, beryllium ion and aluminium have nearly same polarizing power. True, because of diagonal relationship, and hence option number 1 will be the best answer. 74. Identify the incorrect statement of the following. Okay, identify the incorrect statement. This is very important. Atomic weight of tellurium is less than iodine. Wrong. Tellurium is more than iodine. It is 127. If my knowledge serves me right, it is 126. Melting point of Eka silicon, that is nothing but germanium, is low. Absolutely not. These two are wrong statement because it is more. It is around 1200 Kelvin. Okay, clear. Metallic character of sodium is more than lithium. True. Biggest group in the modern periodic table is 3D group. Yes, that is third group, not 3D group. Third group because it consists of actinides and lanthanides. Perfect. So 2 statements are right, 2 statements are wrong, and we needed incorrect. So A and B only. So option number 4 seems to be the best answer. 75. Henry constant values for 4 gases dissolved in water at 298 Kelvin are given below. So these are the KH value. Okay, these are the Henry constant's value. Gases with maximum solubility of the 4 will have value. So it is pretty much simple. If you'll calculate, if you remember Henry's law, which is equal to what? Okay, pressure, that is equal to pressure is equal to K times into its mole fraction. Okay, clear? So at particular temperature this will remain constant. So KH is inversely proportional to solubility. This is, from this we can get the relationship. So if we want maximum solubility, okay, so KH will be minimum. So out of this, the least KH is 10 raised to minus 5, and hence according to me 75, first option will be the right answer. 72. Vapor pressure of a liquid varies with temperature. Which one of the following graphical representation is correct about the variation, where P is equal to vapor pressure of liquid and T is equal to absolute temperature? Here what you can use is Clapeyron equation. Okay, what you can use is what? Clapeyron equation, which says that P is equal to A times E minus delta H of vaporization whole divided by RT. So here if you take, if this P versus T, so this is Y versus X. Okay, clear? So here I can clearly say that option number 1 and option number 4 won't be the answer, because option number 1 shows that it decreases, but rather it shows it is increasing exponentially. So option number 1 is not the right case. Talking about option number 4, it says that y is equal to mx, but that is 0 intercept. That is certainly not possible because there is something over here. Okay, if we'll solve it. So this is not possible. Remaining 3 and 4. So let us take log. So if I take log, it will be log of P equal to log of A minus delta H of vaporization. Wait a sec. Minus delta H of vaporization by R into 1 by T. Log of E tends to 1. Okay, clear? Right. So this is what this is. Let us take it Y, and we have 1 by T and we have T. So let us take 1 by T as X. So this will be X. So that will be equal to, can I say, C minus MX. That is straight line with positive intercept and negative slope. So that will be something like this, and hence option number 2 will be the right answer. Okay. 76. At 298 Kelvin, 12 gram of urea is dissolved in 180 gram of water. Relative lowering of vapor pressure of the solution. So RLVP will be equal to the mole fraction. RLVP will be equal to the mole fraction. That will be equal to number of moles of solute, that is urea, whole divided by number of moles of solution. So talking about number of moles of urea, that will be equal to 12 by 60. So that is 6 2s are 12, that is equal to 0.2. And then number of moles of water will be 180 by 10, that is equal to, 180 by 18. Okay, molecular weight of water is 18, so that is equal to 10. That will be equal to 0.2 whole divided by 10 plus 0.2. That is equal to 0.2, and that is 10.2. So that is equal to 2 by 102, and that is equal to 1 by 51. So option number 3 will be the right answer. Okay. Now vapor pressure of a solution. Okay. Vapor pressure of a solution was mole fraction of a solvent is given containing non-volatile solute. Okay, since the solute is non-volatile, it will not contribute in total pressure. You have to take care of that thing. Is 40 mmHg. Vapor pressure of the same solution when the mole fraction of the solute, here it is solvent, here it is solute, Okay, so first of all, mole fraction of a solvent will be what? 1 minus 0.4, that is equal to 0.6, because vapor pressure will be contributed through solvent, not through the solution, and hence we can use this solution, okay, into, okay, that is partial pressure of a solvent into mole fraction of a solute, okay, mole fraction of a solvent into the what do we say, pure vapor pressure, okay, vapor pressure of a pure solvent. And since temperature remains constant, I can say this will remain what? Constant. This is not going to change. So with this thing, can I say it is P1 upon P2 equal to x1 upon x2, that is mole fraction 1 upon, or that is psi 1 upon psi 2. This implies vapor pressure is how much? 40. Second, we don't know. Vapor pressure at 40, okay, vapor pressure is vapor pressure of the solution where the mole fraction is 0.8 and the second mole fraction is 0.6. So this will be equal to 4 by 3. So that for P2 is equal to 4 into 10, and that is equal to 30. So 30 mm Hg. So 30 mm Hg. Okay, sure. So question number 78, right option will be option number 2. All the following are in single phase except by this thing, if you can see smoke is a colloid which is not a homogeneous, it's a heterogeneous solution. So 79, option number 4 will be the best option. Two volatile liquids A and B forms an ideal solution. Vapor pressure of a pure liquid is this, okay, and the pure liquid B is this. Total vapor pressure of A and B mixture is this. Mole fraction of A in vapor phase will be, mole fraction of A in the vapor phase that they are talking about. So the first thing that we can use is to calculate mole fraction of A in the liquid phase. Okay, so according to Raoult's law, okay, total pressure will be equal to the individual, that is P naught into XA plus P naught B into XB. That can also be written as P naught, or basically what is total pressure of the equation? Total pressure comes out to be 720. P naught A is 800 into mole fraction of A plus P naught B is 400 into 1 minus XA. So that will be 800 XA plus 400 minus 400 XA. So XA will be equal to 720 minus 400 is 320. 800 minus 400 is 400. So this will be 4 8s are 32, that is 0.8. But this is in solution. Okay, by applying Dalton's law, we know that partial pressure of A will be equal to the total pressure into the mole fraction of A. This time I am taking mole fraction of A in the gaseous state as Ya. So with this thing, Ya will be equal to 800 times 0.8 whole divided by 720. So if you solve this thing, okay, so this is 0.1 times and this is 9 8s are 72, so that is 90. So this will go and this will be 8 by 9, so that is equal to 9 9s are 81, almost 81 times. So 0.9 around. So 0.9 around is option number 1. That will be the right answer. Okay. 81. For a system at this temperature, the enthalpy is 150 kilojoule. So delta H is 150 kilojoules and the entropy is 4000 joule. Gives free energy of the system at that temperature. So delta G is equal to 150 minus 300 into 400. Okay, because we know that delta G is equal to delta H minus T delta S. Okay, so this is 150. Remember, this is in kilojoules. So 4 3s are 12. 4 3s are 12. Okay, and this is in joules. So if I want to convert it into kilojoules, so this will get cancelled. So 150 minus 120 kilojoules. So this will be 30. Okay, so this will be what? Plus 30 kilojoules. That is option number 4. Okay. A process is non-spontaneous at all temperature. Non-spontaneous, so delta G will be what? Positive. And to make delta G be positive, so we have an equation delta H minus C delta S. So to make delta G positive, delta H need to be positive and delta S need to be negative. So delta H positive, delta S negative. Option number 4 is the right answer. Which one of the following is correct relationship at 298 Kelvin with an equilibrium constant 2 into 10 raised to minus 3? So we know that delta G is equal to minus RT. Okay, it is minus RT natural log of K. Okay, clear? Minus 8.314 into temperature is 298 Kelvin into natural log of 2 into 10 raised to minus 3. Do we have this equation? Minus 8.3 into 298. Okay, this is one of the equation. Equilibrium, okay, is a correct relationship. So this can be one of the equation because it has 8.314. It has 298 Kelvin and natural log of 2 into 10 raised to minus 3. Okay. Is there any other things? Is there any other thing? No. Okay. Even last option C, minus 8.314, 298 and natural log of 2 into 10 raised to minus 3. Okay. Clear? So Acha, in the first case, if you'll see it carefully, here it's not a standard, okay, but in the last case it is the standard value. Okay, if you'll see the first case it is not a standard, but in the last case it is standard value, and this is what we are calculating for standard value. So option 4 will be the right answer. Oh, sorry, option 4 will be the right answer. See, option number 4. Clear? Sure. Next, absolute value can be determined for entropy by third law of thermodynamics. So we can calculate entropy absolute value by third law of thermodynamics. 85. For a process to be spontaneous, the correct relationship, and you can see delta G and EMF. Okay, so delta G need to be negative, whereas EMF of the cell need to be positive. Where is that equation? This cannot be the answer. Positive. So option number 3 is the right answer. Incorrect statement among the following is: spectrum produced by inert gas is a like spectrum. This is true and hence not the right answer. Spectrum produced by white light is a continuous spectrum. True, not the right answer. Emission spectrum is always continuous. Wrong. Emission can be continuous or discontinuous. So incorrect statement is option number 3. 87. Velocity of electron revolving in a certain orbit of hydrogen is this. Total energy. So we know that velocity of an electron will be equal to 2.18 into 10 raised to 6 meter per second into Z by N. Since it is hydrogen atom, so Z is equal to 1. N value we don't know. So N will be equal to 2.18 into 10 raised to 8 centimeter per second, because the speed is centimeter, divided by 7 into 10 raised to 7. Okay, so to make it 7 into 10 raised to 7, I have to make it 21.8, and then it will be how much? 10 raised to 7 centimeter per second. Okay, and it is 7.27. So this goes approximately 3 times, so N is equal to 3 over here. For N equal to 3, the energy is minus 1.51 electron volt per meter. I always keeps on reminding you, please try to remember these values, very important. For N equal to 1, the value is minus 13.6 electron volt for N1 energy value. For N2, the value is minus 3.4 electron volt. For N3, the value is minus 1.51 electron volt. For N4, the value is minus 0.85 electron volt. So try to remember this value at least for first 4 and 5. That will be helpful. Okay. So 87, option number 1 will be the right answer. 88. An electronic transition in hydrogen atom is occurring from 4th orbit to 2nd orbit. The color of the spectral line observed is. Now here you have to remember, this is a memory based question. Here you have to remember something. Only 4 colors are visible. Okay, only 4 colors are visible. Only 4 colors are visible in Balmer series, and that is Vibgyor. What I remember it in this Vibgyor, that is V B G R, Vibgyor, right? And it is like from 6 to 2, then from 5 to 2, then from 3 to 2, sorry, from 4 to 2, and from 3 to 2. This is how I remember Vibgyor. Okay, and 6543, and Balmer series is 2nd position. Okay, so from 4 to 2, what they have asked is green. For from 4 to 2, what is the answer is green. So option number 1 will be the right answer. Okay, 89. In benzyl alcohol, OH group shows minus I and plus M effect. Wrong. Wait, benzyl alcohol, let me draw. So this is benzyl alcohol. So it does shows minus I, but it does not show plus M. So wrong statement. In chlorobenzene, chlorine group shows minus I, true. Effect only, wrong. It shows plus M effect as well. So option number 4 will be the best option. 89. Most reactive alkyl bromide towards SN1. Most reactive alkyl bromide, that means carbocation stability. More stable the carbocation, more is the stability. N is 1 degree, ISO is 2 degree, TERT is 3 degree. So 3 degree, that means 93rd will be the right answer. Next, most reactive compound towards SN1, again carbocation, make a carbocation, 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 carbocation. And to make and to increase the stability of carbocation, electron donating groups are required. Electron withdrawing group. Electron withdrawing group. So not the answer. 2 and 4 is not the answer. Here I can see OH, OCH3 plus M group. And here nothing. And hence option number 1 will be the best answer. Okay. Again, the following halogen compound is least reactive towards SN1. We know that phenyl and vinyls are least reactive. This is benzyl, not the right answer. This is allyl, not the right answer. And this is alkyl, not the right answer. Option number 1 will be the right answer. Okay. 93. The nucleophilicity is maximum in aqueous solution. We know that in aqueous solution, iodine, bromine, that is iodide, bromide, chloride and fluoride, and in non-aqueous or in polar or protic, it is the opposite. So answer has to be iodine or iodide. Okay. 94. The successive ionization enthalpies for a second period element is 10, 18, 30, 50, 65, 215. That means there is a huge difference between this and this. So this is first ionization, second, third, fourth ionization, and this is the fifth. Okay, first, second, third, fourth, fifth, and this is the sixth ionization. That means, can I say that this element has 5 electrons in valence shell? Yes, that is the conclusion. The formula for its chloride. So it has 5 electrons, so it will accept 3 electrons. So M3, 3, this, so MCl3. So option number 1 will be the best answer. Okay. 95. The noble gas element with the least with the least positive electron gain enthalpy. Least is helium. Okay. Least is what? Helium. If you want to know the order of it, okay, again it's a memory based question. Okay, but if you want to know the order of it, it will be neon greater than argon. That will be equal to krypton. That goes to xenon, then comes radon, and then comes helium. So least. Okay, clear. So option number 1 will be the right answer. 96. In the long form of the periodic table, the element with configuration this. Okay, so which belongs to what? So first of all, what is the atomic number? Radon. So it is helium. Okay, neon, argon, krypton, xenon, radon. So it is 2, add 8 into it becomes 10, again add 8 into it become 18, okay, then add 18 become 36, add 18 it becomes 54, add 32 it becomes 86. So 86 plus 4, 86 plus 4 is 92, that is equal to 90, and 90 is thorium, and thorium is what? Thorium is an F block element, hence the option 96, option number 1 is the right answer. Okay, at 298 Kelvin, 1 bar, pressure is 1 bar, solubility of H2S gas is 0.192 molal. Henry's constant for this gas in water. Okay, now Henry's constant will be what? Okay, at this particular pressure, this is the solubility and this is the constant. Okay, so this is given as 1 bar. We need to calculate XA, we don't know, and we need to calculate KH, which we don't know, but we have given molal. Okay, so from this thing, can I say N of H2S, number of moles of H2S is 0.192, that is approximately equal to 0.2. Okay, and what is the weight of solvent? Weight of solvent, that is equal to 1000 grams, right? So what will be number of moles of water? That is 1000 by 18. So I'll take 1000 by 20 approximately. So that is equal to 50 times, right? So KH will be equal to 1 by, what is Ka? That is 0.2 whole divided by 50 plus 0.2, that is 50.2. Okay, so that will be equal to 50.2 by 2, right? So that is equal to 502 by 2, so that is 2 2s are 4, right? And then 2 5s are 15, 251, something around 251 or more, something more than 251 or something into range of that. So I can see only one option. Why you can see, why we are seeing this ambiguity? Here we have done approximation, here we have done approximation, so we have done approximations over here. So that's why the value will be somewhere nearby 251, and the value near to 251 is 289. So that might be the right answer. Yes, 97, option number 2 is the right answer. Okay. 98. Relative lowering of vapor pressure for a non-aqueous solution containing non-volatile solute is 0.3. Molality of the solution is, okay, now we know that RLVP is equal to this, right? So relative lowering of vapor pressure is it, that means X of solute is how much? 0.3. So X of solvent will be how much, or mole fraction of solvent will be how much? 0.7. Clear? Sure. What is molality? Molality will be equal to how much? Molality will be equal to solute into 1000 whole divided by weight of, so that is equal to 0.3 into 1000. Now weight of solvent, talking about weight of solvent, weight of solvent will be equal to how much? Weight of solvent will be equal to 0.7, because this is solvent and this is the mole fraction. Okay, so this will be what? 0.7 into molecular weight of solvent is how much? 200, so it is 200. Okay, clear? So if you'll solve this thing, okay, if you'll solve this thing, you will get answer. Okay, you'll get answer around 0.2 around. Okay, that is C1 gone, right? So this is what? 3 by 7. Okay, 3 by 7 into 10 by 2. So this is 2 5s are 10, right? 5 3s are 15. So 15 by 2. So this is 2 7s are 14. Okay, this is 2 7s are 14. Sorry, 7. So it is 7 2s are 14. Something around 2. So the right answer will be what? Something around 2. Okay, so 98, option number 3 is the right answer. It is more than 2 as a matter of fact. That's why we have not taken 1.89, we have taken more than 2 value. Okay, so 98, option number 3 is the right answer. Two volatile liquids A and B mix together in the mole ratio. So A, Na is to Nb is equal to how much? 3 is to 2. forms an ideal solution. Vapor pressure of pure A, P naught A, is equal to how much? 500, whereas P naught B is equal to 900. Mole fraction of B in vapor phase. Again vapor phase. So first of all we have to apply Raoult's law and then we have to apply Dalton's law. Okay. So Na and Nb is given. To apply Raoult's law we require mole fraction. So Xa will be 3 by 5 and Xb will be 2 by 5. High 3 by 5. For Na it will be 3. 3 plus 2, that is 5. Xb is what? 2. That means 2 by 5. Okay. So total pressure. Okay. Clear? Or in spite of doing that, total pressure Pt will be equal to P naught A, mole fraction of A, plus P naught B, mole fraction of B. So P naught A is 500 into 3 by 5 plus 900 into 2 by 5. Okay, so this is 100 times, so this is 300. Okay, plus this is 18 times, so that is 180 times, so that is 360, and hence total pressure will be equal to 660. This is the total pressure and these are the individual pressures of A and B. Okay, what is needed is mole fraction of B in the vapor phase. Okay, so mole fraction of B in the vapor phase can be calculated by Dalton's law. We have just used this thing couple of questions back. Okay, so Dalton's law will be equal to what? Partial pressure of B will be equal to the total pressure into mole fraction of B in the vapor phase. Okay, so YB is equal to, what is the partial pressure of B? 360 whole divided by 660, right? So 6 6 are 36 and it is 11. Got it? So it is definitely less than 11 6 are 66. Okay, so it is 11 5 are 55. So it is definitely less than 6 and more than 5. So it will be the range will be from 0.5 to 0.6. Okay, so 0.5 to 0.6, the only range that fits is option number 4, and 99 option number 4 will be the right answer. Okay, 100. For a chemical reaction A to B, delta H is this and this is this. Okay, the spontaneous. So we know that at equilibrium the reactions are spontaneous and delta G is equal to 0. So that will give you delta H by T delta and delta S. So that is 60 into 1000 whole divided by 20, and this is 3. So it is 3000 Kelvin temperature. Now the question that is asked is, the process is spontaneous at, okay, the process is spontaneous at, delta H is positive, right? Delta H is what? Positive, and delta this thing. So that means if you want process to be positive, so the spontaneous, delta H minus T delta S. At temperature 3000 Kelvin, this will become equal to 0. And now if you want less value, that means if you want delta G to be negative, temperature should be more than 3000 Kelvin. Temperature should be more than what? 3000 Kelvin. Then and only then minus T delta S value will become minus. Okay. Or this T delta S value will go beyond delta H value, and hence we can have delta H equal to negative value. So for this last question, the right answer will be option number 3. Clear? So I hope guys you must have understood all the questions and the solutions of it which came in your unit test number 5. So with this thing guys, thank you so very much for joining this solution video. Take care guys. We'll meet and discuss the next paper solution next time. Thank you so very much. God bless you all.